So today we are going to do lab 2, which is global energy balance and temperature distribution. For our first task, what we'll do, we will show you how the length of the day and the season is happening, how the length of the day is changing, day and night is changing because of the different time of the year, how is the solar radiation changes throughout the year. Okay, so for that we have 4 different locations. One is March, which is spring, then summer, June. In that location it's September. Okay, so the tag is here. September, which is fall, and this is winter, December. So we'll show how the radiation from the sun, from the solar energy changes based on the different location. So for that, so you can you please come closer? Okay. So here, so this is our Earth. So Earth is tilted in its axis by 23.5 degree. Okay, and this point, suppose this is Manhattan. Okay, so the tilt will be like that, and the Manhattan will always face the sun. We'll do that for all 4 locations, and we'll draw a line to differentiate between the lighted portion and the dark portion. So that's our sun, by the way. So Ricardo, can you please draw the line? Approximately, yeah. You can draw for northern hemisphere only, it would be fine. Yeah. So we are drawing line for the northern hemisphere only. So that's for March. Okay, so
the red one.
So we are using different colors for different month. Okay, so red we are using for March. So the Earth is rotating, right? So again, the tilt we are not changing, only we are changing. So Manhattan, it will face to the sun. So you can see in June the lighted portion. We'll show you after the drawing how it's changing. So it's a little more light. And we are using pink for summer, and we are using green for the fall. So again, same thing, just rotating it, and you'll see the September and March, the line is kind of similar. Okay, and now for December, which is winter. We are using blue. Okay, so we have drawn 4 different lines for 4 different months. Okay, so let's discuss. Yeah. So you can see this is Manhattan. So red one and green one. Red one was for March, green one was for September, which means red one is spring, green one is fall. You can see the length of the day in northern hemisphere. The lighted portion is kind of similar for spring and fall. For summer, you can see, so this is our North Pole. Okay, so this is the North Pole. For summer, you can see the pink line. So sun was in that side, so the length of the day, we are getting more sunlight, so the length of the day has increased in summer. Oppositely, in December, you can see the blue line. It's for December. We are getting less sunlight, which means the length of the day is less, the length of the night is increased. So you can see we are getting less sunlight. So less sunlight means we are getting less temperature, less solar radiation from the sun, so it's winter. Okay, so that's the model you need to understand, like how the solar radiation changes throughout the year. Okay. Okay, so we are getting sunlight at a 90-degree angle, so we are drawing lines approximately Okay, so that is for 90-degree angle. And now we can do.
Do you want another color?
It's fine. From 60-degree angle, okay. 60-degree angle, we are getting. Okay, and for about 30-degree angle. Okay, so now we'll count the number of blocks, how it's covered. So this one, okay, it's better to use another color. So next.
No, but it's the center one, this one, and this one.
Okay, so this is the 90-degree one. So approximately we are counting cells. So about 34 cells for 90-degree angle. Okay. So for 60 degrees, so those are 34. So 57 cells for 60 degree, and for the last one, which is 30 degree, so you can see, suppose we are getting 10 watts of energy from this flashlight. The energy amount of energy has not changed, but for 90 degree it's covering 34 cells. So suppose one cell, the area of one cell, suppose it's 1 centimeter square. Okay, so for 90 degree the area it is covering 34 square centimeter. For 60 degree it's covering 57 square centimeter. For 30 degree it's covering 92 centimeter square. Okay, so it's for 90, this is for 60, this is for 30. So you can see, suppose now imagine it's in a sunny day. Okay, so in the morning we are getting sunlight, like in the morning or in the evening near dusk. So we are getting sunlight at a 30 degree angle. So we are getting the same sunlight, but it's spread over a larger area. Where in the noon we are getting sunlight at about 90 degree angle. We're getting the same sunlight, but it is more concentrated in less area. So we will feel more temperature at noon, but near dawn or near dusk we'll feel less temperature. We're getting the same energy, but the amount of energy it's changing because the energy is spreading for a large area, and the energy is concentrating for a small area. So that's how the energy per area, per unit area has changed because of the change of the angle. Okay.